In the previous set of notes, we found the slope of parallel and perpendicular lines. Well, today we're going to be finding the equation of parallel and perpendicular lines. Now, we're first going to go ahead and start off by talking about parallel lines. We're going to find the equation of parallel lines. Now, remember from yesterday, anytime I'm looking for the slope of a line that is perpendicular to a given equation and I'm trying to see if it's parallel, it has to have the same slope. So, again, like I said, we're going to find the equation of parallel lines first. So looking at number 1, it says write the equations of the line, or write the equation of the line that is parallel to the line y equals negative 4x plus 10 and has a y-intercept of negative 10. So if I look at this equation, I want to find the slope of the line that is parallel to my given line. If I look at this equation, my slope is negative 4. And if I'm trying to find the equation of the line that is parallel to this given equation, remember, it has to have the same slope. So the slope of my line would be negative 4. So the equation that I'm trying to write will be in the form y equals mx plus b. I want this in slope-intercept form. So I already know that my m is negative 4, and it tells me my y-intercept is 0, negative 8. So that tells me that b equals negative 8. So I'm going to take these two pieces of information and plug them into my formula, my slope-intercept formula. So I have y equals, my m would be negative 4x, and then my b would be negative 8. So I would subtract 8. So again, as you can see here, they are parallel because they have the same slopes of negative 4. So again, our equation is y equals negative 4x minus 8. Let's go ahead and look at another example. So number 2 says write an equation of the line that is parallel to the line 2x minus 3y equals 12 and crosses the y-axis at 6. So before I can determine what slope would be parallel to this line, it has to be in slope-intercept form. So I want to solve for y. Remember, there's 2 steps when I solve for y. Move x and divide by the number in front of y. So here, I'm going to subtract by 2x to both sides. So my 2x cancels. I'm going to bring down the negative 3y equals. And again, since I want this in slope-intercept form, my x comes first. So negative 2x plus 12. Now, again, I want this to say y equals, not negative 3y equals, so I have to simplify this. So I'm going to divide both sides by negative 3, or all numbers by negative 3. When I do this, the negative 3 cancels. I'm left with y equals. Then I take this fraction, negative 2 over negative 3. When you simplify this fraction, if you put it in your calculator, you will get 2 over 3x. Then 12 divided by negative 3, if you put that in your calculator, you will get negative 4. So here is my equation when it's in slope-intercept form. So if I want to write an equation of the line that is parallel to this line, my slope has to be the same. So my slope would have to be 2 over 3. So m would be 2 over 3. And it says it crosses the y-axis at 6. So my y-intercept is 6. My b would be 6. Now that I know my slope and my y-intercept of the equation I'm trying to write, again, I'm going to put this into the form y equals mx plus b. So I'm just going to drop in my information. So I have y equals 2 over 3x plus my y-intercept, which is 6. So here your equation is y equals 2 over 3x plus 6. So that's numbers 1 and 2. Again, just to reiterate, your slopes have to be the same in order for your lines to be parallel. So again, all I did was find the slope from my original equation, and that should be the slope of my new equation. and then my y-intercept is where it crosses the y-axis. So that's numbers 1 and 2. Let's go ahead and move on. We're now going to look at numbers 3 and 4. So number 4 says, write an equation in slope-intercept form. It should say for a line that is parallel to y equals 1 over 4x minus 9 and passes through the point 8, 1. So again, I'm looking for the equation that is parallel. So if I look at this equation, my slope is 1 over 4. So my m equals 1 over 4. So again, if I'm trying to write my equation in slope-intercept form for the line that is parallel to the given equation, again, it has to have the same slope. So that's 1 over 4. Then they give me a point, 8, 1. In order for me to write my equation in slope-intercept form, I have to have my slope and my y-intercept. But in this problem, I have my slope and a point off the line. So we're going to go back to what we learned on Monday, and we're going to use point slope form to find our equation. So point slope form is y minus y1 equals m parentheses x minus x1. So looking at our point, by the way, remember we always want to label it x1, y1. And now we substitute what we know. We know our slope and we know our point into our equation. So we have y minus y1, which is 1, equals our slope, which is m, which is 1 over 4, parentheses x minus x1, which is 8. But this is not my final answer. Again, I want my equation in slope-intercept form. So this means I have to solve for y. And remember, when we're solving for y, anytime I'm solving an equation in general, the first thing I always want to do is get rid of the parentheses. So I'm going to bring down y minus 1 equals. Now I'm going to distribute. 1 over 4 times x is going to give me 1 over 4x. 1 over 4 times negative 8. So when you put this in your calculator, you'll type control divide. 1 over 4, step out of your fraction, times negative 8. Now if you do this by hand, negative 8 over 1 you multiply across, negative 8 divided by 4 gives you negative 2. So this would be minus 2. Now again, I want to solve for y. And in order to get y all by itself, right now it's being subtracted by 1. So I want to do the opposite and add 1 to both sides. When I add 1 to both sides, this cancels out, and I'm left with y equals 1 over 4x, and negative 2 plus 1, when you put that in your calculator, will give you negative 1. So this is the equation in slope-intercept form for the line that is parallel to y equals 1 over 4x minus 9. Now let's go ahead and take a look at number 4. So number 4 says, write the equation of the line that contains the point 5, 11 and is parallel to the line y minus 3 equals negative 2 over x plus 4. Now this is kind of a good time to go over graphing an equation in point slope form again. So if I look at my current equation, again, this is in point slope form. So I'm going to rewrite the point slope formula below it. So y minus y1 equals m parentheses x minus x1. So if I look at this problem, my slope is negative 2. Now, if I want to write out my point, remember, your point is always opposite of how it appears in the equation. And remember, our point is always x1, y1. So if I look at my x value, right now it is a positive 4. Remember, it's always opposite of how it appears in the equation. So if x1 is a positive 4 in the equation, the point is actually negative 4 for your x value. And if y1 is negative 3, your y1 value is actually a positive 3. So now you want to go ahead and plot this point on your graph. So from the origin, by the way, this is my x-axis, this is my y-axis. From the origin, I want to go plot a point at negative 4, 3. So if my x value is negative 4, I'm going to move to negative 4 on the x-axis. And if my y value is a positive 3, I want to move up to 3 and plot a point here, which is at negative 4, 3. So now looking at my slope, I have negative 2. And remember, anytime you have a slope that's a whole number, you're supposed to put it over 1. So what this is telling me to do is go down 2, right 1. So I'm going to plot this line, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. Now that takes care of all of the points on the right side of my point. Now I want to plot the points on the left side of negative 4, 3. So now I'm going to go up to left 1, up to left 1, and now I'm going to go ahead and connect my dots. So that's just graphing the line I was originally given. Our goal, again, is to find the equation of the line that is parallel to it. And it has to go through the point 5, 1. So again, my slope should be the same. So my slope for my new line should still be negative 2 because, again, it's parallel. And parallel lines should have the same slope. So again, I'm going to use the slope formula, y minus y1 equals m parentheses x minus x1. And I'm using this formula because I have been given a slope and I have been given a point off of my line other than my y-intercept. So I'm going to go ahead and substitute in my information. I'm going to rewrite the point 5, 1 over here. That way I can label it as x1, y1. And again, I always suggest that you label it in order to avoid mistakes. So I have y minus y1, which is 1, equals m, my slope, which is negative 2, parentheses x minus x1, which is 5. Now I go ahead and solve for y. So I'm going to bring down y minus 1 equals, and again, I have to get rid of these parentheses. So negative 2 times x is negative 2x, and negative 2 times negative 5 is a positive 10. But again, I'm not done. I have to get rid of these, this negative 1. I want to get y all by itself. So I'm going to add 1 to both sides. When I do this, this cancels out, and I'm left with y equals negative 2x plus 11. So here is the equation of the line that contains the point 5, 11 and is parallel to the line y minus 3 equals negative 2 parentheses x plus 4. But now we run into a problem. I can't exactly graph this in slope-intercept form. It's hard for me to graph. So what we're going to do, we're going to go back to our point, 5, 1, and we're going to go ahead and graph that point on our graph. So my x value is 5, so I'm going to go to 5 on the x-axis, and my y value is 1, so I'm going to go up 1, and I'm going to plot that point. Now, remember, since your slope was negative 2, in order to plot the rest of my points, I'm going to go down 2, right 1, down 2, right 1, down 2, right 1. Now that takes care of plotting the points on the right side of 5, 1. I still have to plot the points on the left. So now I'm going up 2, left 1, up 2, left 1, up 2, left 1. And again here, after plotting your points, you'll see that they are parallel to each other. So that is finding the equation of a parallel line. Let's go ahead and find the equations of perpendicular lines now. So, number 5 says write the slope and equation in slope-intercept form of a line that is perpendicular to y equals negative 1/3 x minus 7 and contains the point negative 2, 7. So, to begin, I want to look at the slope that I currently have. My slope is negative 1/3. But remember, I want to find the slope that is perpendicular to this because my equation, my line has to be perpendicular to my overall equation. So remember, when we find perpendicular slopes, my denominator goes to my numerator goes to my denominator. I flip my fraction. So now it's -3/1, but remember, my sign also has to change. So it's no longer a negative, now it's a +3/1, and +3/1 equals 3. So here my slope is 3. And again, I want to find the equation in slope-intercept form. And the two pieces of information I need in order to write my equation in slope-intercept form are my slope and my y-intercept, which I don't have. I have my slope and I have a point off my line, which means that I can use point-slope form to find my equation, which is y minus y1 equals m parentheses x minus x1. So my point, -2, I'm going to label as x1, y1. And my slope, again, is 3. So I'm going to go ahead and plug in this information into the formula. So I have y minus 7 equals m, which is 3, parentheses x minus x1, which is -2. Now remember, after you've put in all of your information into the point slope formula, you have to go back and check for double signs. We see that we have two negatives here, which means that it now becomes an addition sign. So again, we want this to be in slope-intercept form. Okay, I want it to be in the form y equals mx plus b. So now I have to solve for y. So when I'm solving for y, the first thing I do is get rid of the parentheses. So I'm going to bring down y minus 7 equals 3 times x is 3x, and 3 times 2 is 6. Okay, now again, I'm solving for y. I want to get y all by itself. So right now I have 7 being subtracted, so now I'm going to add 7 instead. So I add 7 to both sides. I'm left with y equals 3x, and 6 plus 7 is 13. So here, the equation in slope-intercept form of a line that is perpendicular to y equals -1/3 x minus 7 and contains the point -2, is y equals 3x plus 13. Let's go ahead and move on. Let's look at number 6. So number 6 says, write the slope and equation in slope-intercept form of a line that is perpendicular to y equals 6x plus 4 and contains the point 12, -5. Before I can write this equation, we again have to find the slope of the line that is perpendicular to y equals 6x plus 4. So again, I'm going to take my slope of 6 that is in my given equation. And remember, anytime I have a slope that is a whole number, I put it over 1. And I want to find the opposite reciprocal. So I'm going to flip my fraction and it becomes 1/6 and my sign changes. So now I have -1/6 as my slope. So now that I have my slope and I know a point from the equation, again, I want to get this into slope-intercept form though. Since I've been given a slope, or since I have found my slope and I have been given a point, I have to use point-slope form in order to transform my equation into slope-intercept form. So I have y minus y1 equals m parentheses x minus x1. So substituting in my information, y minus y1, which is -5, equals m, which is -1/6, parentheses x minus x1, which is 12. Now we go back and check for double signs. In this problem, we have double signs right here. Y minus -5 becomes y plus 5. So now, again, since I want this in slope-intercept form, I'm solving for y. And remember, the first thing we always do is get rid of the parentheses. So I'm going to bring down y plus 5 equals, and now I'm going to distribute. -1/6 times x is -1/6x. -1/6 times -12. So if you put that in your calculator, you'll put control divide -1/6 times 12. And if you're doing this, I don't have a calculator on me, so I'm going to put this over 1 and I'm going to multiply across. Negative 1 times negative 12, that's a positive 12, divided by 6 times 1, which is a positive 6, which equals 2. So plus 2. Again, I'm solving for y, so now my next step is to subtract 5 to both sides. Okay, now I'm left with y equals negative 1 over 6x, and 2 minus 5 is negative 3. So here the equation of the line that is perpendicular to y equals 6x plus 4 and contains the point 12, negative 5 is y equals negative 1 over 6x minus 3. Okay, so that's numbers 5 and 6. Now let's go ahead and continue. We're going to look at number 7 and number 8. So number 7 says, write the slope and equation in slope-intercept form of a line that is perpendicular to y equals 3 over 4x plus 1 and contains the point 0, 3. So to begin, I want to find the slope that is perpendicular to 3 over 4x plus 1. So if I'm finding the slope that is perpendicular to this, remember I have to find the opposite reciprocal. So I'm going to flip my fraction and change the sign. So negative 4 over 3 is my slope. And it has to contain the point 0, 3. Now, if you're not able to recognize that 0, 3, this is your y-intercept. Okay? If you cannot recognize that, you can put both your slope and this point into the point slope formula. So I can go ahead and solve it that way, x1, y1, and then once I solve it that way, I'll show you another way. So I have y minus y1 equals m parentheses x minus x1. So I have y minus 3 equals negative 4 over 3 parentheses x minus x1, which is 0. Now I solve for y. So when I solve for y, again, I want to get rid of the parentheses. So I'm going to drop down the y minus 3 equals negative 4 over 3x, and negative 4 over 3 times negative 0 is just 0. So I don't have to put plus 0. Now I want to go ahead and add 3 to both sides. So this cancels, and I'm left with y equals negative 4 over 3x plus 3. So this is the equation of my line. Y equals negative 4 over 3x plus 3. Now, if you were able to recognize that 0, 3 is your y-intercept, you could have automatically gone and used a slope-intercept form, which is y equals mx plus b, and substituted in your information. So we would have seen that y equals my slope, which again was negative 4 over 3x, plus my y-intercept, my b, would have been 3 here. So plus 3. Here you'll see that you'll get the same thing no matter which method you would have used. So that's number 7. Now we're going to go ahead and look at number 8. So number 8 says, write the equation of the line that contains the point 7, 7 and is perpendicular to the line 3x plus 2y equals negative 4. So again, this is in standard form and I want it to be in slope-intercept form. So I have to solve for y. So my first step, I'm going to subtract 3x to both sides. If the 3x cancels, I'm going to bring down 2y equals negative 3x minus 4. Now again, I'm solving for y, so I'm going to divide everything by 2. So my 2's cancel. I'm left with y equals negative 3 over 2x. And negative 4 divided by 2 is going to give you negative 2. So again, if I'm finding the equation of the line that is perpendicular to this, I again want to start off by finding the slope that is perpendicular to this equation. So if my slope is negative 3 over 2, I want to find the opposite reciprocal. So I'm going to flip my fraction. So now I have negative 2 over 3. And I want to change my sign. So now it's a positive 2 over 3. So now that I know my slope, now that I've been given a point, which is x1, y1, I'm going to go ahead and plug in this information to find the equation that is perpendicular to the given equation. And the only way I can do that is by using the point slope form, which is y minus y1 equals m parentheses x minus x1. So I substitute in my information. Y minus 7 equals m, which is 2/3, parentheses x minus x1, which is also 7. Now I solve for y. So I bring down y minus 7 equals, I'm distributing 2 over 3 times x is 2 over 3x. 2 over 3 times negative 7. So again, I don't have a calculator. So you're going to type in control divide, 2 on top, 3 on the bottom. Step out of your fraction times negative 7. Since I don't have a calculator, I'm going to put this over 1 and multiply straight across. So 2 times negative 7 is negative 14. 3 times 1 is 3. And I actually cannot simplify negative 14 over 3 any further. So negative 14 over 3. Now I'm going to add 7 to both sides. So this cancels. And I'm left with, I'm going to write on here, y equals 2 over 3x. And now in your calculators, type in negative 14 over 3, step out of your fraction, and add 7. Now, when you type that in, you will see that you get a positive 7/3. So I'm going to rewrite this to where you can see it a bit better. You have y. I'm going to go ahead and erase this so I'll write out my final answer here. Your final answer again is y equals 2 over 3x plus 7 over 3. Now, that's really ugly in order for you to graph it. So, use the point that you've been given. Use the point 7, 7. Go ahead and plot that on your graph, 7, 7. Now, if I use my slope of 2/3, that means I go up 2 and right 3. I can't do it. So, I'm going to do the opposite and I'm going to go down 2, left 3. Down 2, left 3. Down 2, left 3. Down 2, left 3, and down 2, left 3. And if I plot the point of my given equation, if I plot the line y equals negative 3 over 2x minus 2, my m is negative 3 over 2, my b is negative 2, and I use my slope, negative 3 over 2, negative 3 over 2, up 3, left 2, up 3, left 2, up 3, left 2. When we graph this, we see that it forms a 90-degree angle. It forms a perpendicular right angle. Okay, so that is finding the equations of parallel lines and perpendicular lines. Now let's go ahead and take a look at lines that are parallel to the x and y axis. So a line that is parallel to the x axis will be horizontal and have a slope of 0. Anytime I have a line that is parallel to the y-axis, the equation for that will be y equals some number. So for example, let's say I have this line right here. This equation for this line would be y equals 3. It has a slope of 0, and it is horizontal. It is parallel to the x-axis. This is the x-axis. Okay? Then I have a line that is parallel to the y-axis. This will be vertical and have an undefined slope. Vertical lines, the equation for a vertical line would be x equals some number. So, for instance, if I have this line, this would be x equals -3. We see that it is a vertical line, and we know that vertical lines have an undefined slope. Again, we see that this is parallel to the y-axis. This is the y-axis. So number 9 says, write the equation of the line that contains the point -3, 2, and is parallel to the x-axis. So the first thing I'm going to do is actually plot this point, -3, 2. Here's my x value, here's my y value. Here's my x-axis, here's my y-axis. So from the origin, I'm going to go to -3 on my x-axis because that's my x value. And then I'm going to go up to 2. So here's my point, -3, 2. Now, I want this to be parallel to the x-axis. So if it's parallel to the x-axis, here's my x-axis. I don't want it to touch. So that means I want to have a horizontal line. I want it to go from side to side. Now, when I look at the equation or when I'm trying to find the equation of this line, I see that this line hits the y-axis. So the equation would be y equals 2. And my slope, again, would be 0. So that is parallel lines to the x and y axis. Now let's go ahead and find lines that are perpendicular to the x and y axis. So a line that is perpendicular to the x axis will be vertical and have a slope of 0. It will have a 0 slope. So if I have a line that is perpendicular to the x-axis and it's vertical, that means that the equation of the line will be x equals some number. So for instance, if I draw this line, I see that it is perpendicular to my x-axis. I see that it is creating a 90-degree angle. So here this would be x equals 3, for instance. I'm sorry, it does not have a slope of 0. It has a slope of undefined, undef. So here again, my line is vertical. It goes up and down, so it has an undefined slope. And again, it forms a 90-degree angle with my x-axis, which tells us that it is perpendicular. So a line perpendicular to the y-axis will be horizontal. And it will have a slope of 0. And so its equation will be y equals some number. So for instance, if I have my graph here, again, this is my y-axis, and I see that it just created a 90-degree angle. So this was perpendicular to the y-axis, and its equation is y equals 2. So again, we see that it forms a 90-degree angle with the y-axis. And again, its graph would be y equals some sort of number and have a slope of 0. So let's go and look at the problem. Number 10, write the equation of the line that contains the point 1, -4 and is perpendicular to the x-axis. So the first thing I'm going to do is plot this point, x1, y1. It's probably, I could have just put x comma y because I'm not going to write an equation. Or I am, but I don't really need my point for it. So x comma y. So again, this is my x-axis, this is my this is my x-axis, this is my y-axis. So I'm going to go ahead and plot my point. Starting off at the origin, my x value is 1, so I'm going to move to 1 on my x-axis, and my y value is -4. So I'm going to move down to -4. Now, since I want this to be perpendicular to the x-axis, if I have a line that is perpendicular to the x-axis, it's going to be vertical and have an undefined slope. So my line will go up and down. So since this line crosses the x-axis at 1, it hits the x-axis at 1, the equation will be x equals 1. Okay, that completes your notes going over equations of parallel and perpendicular lines.